Hey guys, welcome back. It's Monday, April 20th. We are starting Unit 7, which is Introduction to Vectors. And today we're going to be adding vectors both graphically and numerically. This should not take very long at all. So I'm just going to kind of show you, kind of explain what a vector is. And I'll show you on Delta Math how to do your assignments, and we'll be done for the day. And even the assignment's only 10 questions. So today's not going to be a very long or difficult lesson. So I hope everybody's doing well. Miss you guys. Miss seeing different people every day. So a vector is a quantity that has both distance and it has what's called magnitude and direction. So we have magnitude and direction. Okay. So a vector is going to look like a ray from geometry. So you've got what's called the initial point down here at O, and a terminal point which has an arrow on it. It actually does not go on forever. That's how it's a little bit different from a ray or a geometric ray. So it's called its terminal point, and since it does have magnitude, that's another word for length. Okay, it definitely has a measurable distance to it, and so it looks like a ray, but it just has different like meaning to it. There's two different ways we can denote a ray. You'll see it written down a couple different ways in Delta Math, and it may be any worksheets that we end up doing together. So the initial point is O, the terminal point is P, and we have to draw a vector on top of that, which kind of looks like a ray, except it only has one little arrow. It doesn't have the second arrow. So that's how we determine the difference between a vector and a ray. So again, that little symbol on the top only has the one little half arrow on top of it. The other way we can name this is, if you'll see here in the middle, there's a V. So this is also called vector V. And this little printout, actually, you guys, I set this up on the blog for you guys to print this out. So if you haven't seen that already, maybe try printing this out and putting it in your notebook. Again, notebook is something you're still going to want to be keeping up with, because as you move on to college, this is going to come in handy later on. Okay? So the length of the vector is also called magnitude, as we talked about earlier. For the purposes of what we'll be doing today, we'll measure it in centimeters, but for the most part, it's not really going to be measured in centimeters. It can be measured in a whole bunch of different things like miles or meters or feet or whatever. And we use the absolute value of V, it's represented as. And so we have, this is the absolute value of it. So it never has a negative value. It doesn't matter which direction it goes. It's always going to be a positive value. Length, for what we're going to be doing, you'll be able to use the Pythagorean theorem for to get its magnitude. So we'll be doing a lot of a squaring and b squaring to get c squaring. And then the other part of the definition of a vector is its direction. And the direction of the vector is the directed angle between, let me just make sure I get this right, the directed angle, oh, come on, between, the positive x-axis, the horizontal axis, and the vector itself. So when you look at, so I'll slide this up just a little bit. So when you look at this vector, the horizontal is here. And so the direction is going to be that angle that's created between the horizontal and the vector itself. So what is that angle? That's what we refer to as the direction of the vector. So is it going 30 degrees? Is it going 285 degrees? You know, what's it doing? A vector in standard position will have its initial point at the origin, as we have started every single angle in our trigonometry units. Okay. Just to show you how to measure to get the length and direction. Where did I put my protractor? Okay, so I'm going to use a protractor, which is backwards. I'm going to use a protractor to measure both its length and its angle measure from the horizontal. So this isn't something you're going to have to do because you're sitting at home, but you could probably see that this vector is 3 centimeters long. So it's stopping right there at the 3 centimeters. So this is 3 centimeters. And so I'll use the protractor, set it up so that its initial point is sitting in that little bitty circle right there. And what I might need to do is extend that vector out a little bit. And so what you might be able to see there is that this vector is heading out at 40 degrees. So we would say that this vector, its magnitude is 3 centimeters, and its direction is 40 degrees. So those are the two, that's what makes it a vector, that it has two measurable components to it, both a length and an angle measure that it's taken off at. Okay, do that one more time over here on B. It's going to be a little tougher because it's a small vector. But it appears that this is going to be about 1.2-ish, 1.3-ish, 1.3 centimeters. And the direction is going to be a little tougher because it's so small. So I'll have to extend that out a little bit. Get that set up at the initial point. And you might be able to see that the pencil mark's coming right through here. 130, that's going to be 125, that's 130 here. So we're probably looking at about 127, 127 degrees. Okay, so that's going to be the basics of the geometric vectors. You know, they have two different measurable components, a magnitude, which is its length, and the direction, which is an angle measure that comes from the horizontal axis. So that's the introduction to vectors. This next page just shows you a couple of different ways to add vectors. I typically am going to use the triangle law, where you have one vector and you take the second vector and you put it at the end of the first vector. So this is the first vector, this is the second vector, and the one that connects those here in the middle, that's called the resultant, otherwise known as the answer vector. Okay, so that's not that it's a good page, not that super important of a page. So let's transition over to what your Delta Math is going to look like for homework. So the hardest part for me right now is going to get the computer set up in the screen so that you can see it. So bear with me for just a second as I get this set up for you. Okay, I think that's about it right there. All right, so here is, let's go to the next problem. This is what your problem is going to look like. Get that down a little bit. And so you're going to be given a vector called u, given another vector called v, and I want you to add those two together and write the result in what's called component form. And the component form looks like this. So the component form just looks like an XY form of like an ordered pair. The difference is you've got these weird brackets on the left and the weird bracket on the right. And that's just the way that vectors are written when they're in component form. So what it wants you to do, it says to click and drag either vector to add it graphically. So you can grab either vector, doesn't matter which one. But what it wants you to do is it wants you to take one vector and put it at the end of the other vector and drop it. And as soon as you have it dropped, then it's going to allow you to come down here and actually add the two vectors together. And adding vectors numerically is simply adding the -6 to the -2. We're literally adding the x's and we're going to add the y's. So -6 plus -2 is going to be -8. And then the y parts of it, 4 plus -6 is going to be -2. I'll submit the answer and you'll see that we got that right. And then what it's going to do, it's going to show you the resultant vector there in orange. Now, later on in future units, we're going to have you guys draw that resultant vector in. And then it also shows you the resultant vector's answer, -8, -2. And so what that does, it is a horizontal and negative movement. So if we started here and we went left 8 and down 2, then that's where we get to. So that makes that resultant vector. So basically what it's saying is it's giving you a direction. It's saying, hey, so the new vector is going to be from the origin -8 units and then -2 units. So left 8, down 2. So the other part, let's see if I can get that off my screen. The other part of the homework, adding vectors numerically, is a lot simpler. Here, they simply just want you to add the vectors together. So we're adding the x's and we're adding the y's. So -4 plus 7 is going to be -3. The y parts, -3 plus -3 is -6. Boom. There it is. We got it right. Oh, hang on. What did we do wrong? Should be a +3. Sure, you guys caught that. Good job. +3. And you do see down here it does give you a couple different attempts to get it right. So that should be better. Okay? Be careful with your signs. Go back. You have 10 Delta Math problems. 10 of each one of these, 5 of each of these sections. It shouldn't take you guys very long. Hope you guys have a great day. It's good to talk to you. Look forward to hearing from you. Have a great day.